And good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture to be or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All righty then. So today we're going to eventually cover 10.4, and we're actually going to cover 10.4 today and tomorrow, as well as the chapter review. It's a long section. I don't know how far I'll get today, but I'll pick it up tomorrow wherever we leave off today. So we'll see how that goes. But first of all, do you have any questions from 10.2?
No, I don't.
Greg, how about you?
No, I don't have any questions.
All righty. Then we'll go on to section 10.4, which is graphing. So what I want to do now, actually, I'm going to switch to a different screen. And let's see here, let's move that down there. Okay, put on my glasses here so I can see what I'm doing. That. All right. So in the past, we've graphed linear equations, which were straight lines. Now we're going to graph second degree equations. And in doing so, we're going to get what is called a parabola. P-A-R-A. See, parabola, B-A-R-A-B-O-L-A, okay. All right. Let's start off with a very basic one, which is y equals x squared. Now, whenever I'm graphing something that I don't really know much about, I always start by graphing using x going from -3 to +3. So that's what I'm going to do here. Okay. Now, when x is -3, we would get y equals -3, the quantity squared. Notice that x is squared. Since x is -3, all of the -3 gets squared. The negative is inside the square process. -3, the quantity squared is 9. Any questions about that? All right, continuing on, if x is -2, y equals -2, the quantity squared, which is 4. If x is -1, y equals -1, the quantity squared, which is 1. Y equals 0 squared, which is 0. Y equals 1 squared, which is 1. Y equals 2 squared, which is 4. And y equals 3 squared, which is 9. Okay. Now, I want you to notice that we have, oops, here we go, some values that are the same. These have the same y values. These have the same y values. These have the same y values. But that's okay. It's still a function. Two different x values can go to the same y value. We just can't have one x go to both y values or to two different y values. So in fact, I could have written it, let's say f of x equals x squared. Okay, could have done that. Didn't, but could have. All right. Back to the black there. So now I'm going to plot my points. -3, 9 is right there. -2, 4 is right there. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Obviously, either I messed up really big time or it's not a straight line. And thankfully, I didn't mess up. It isn't a straight line. Again, it's what we call a parabola. And it looks, let's see how well I can graph this. Close, but Okay. Sort of that, I don't know, horseshoe shape or somebody's tongue sticking out or whatever. Anyway, and again, I didn't do a perfect job of that, but a couple things I want to point out. Okay, this parabola we say is opening upwards. This point, that's the low point of the parabola opening upwards, is called the vertex. Okay. No, remember that there were some repeated values. So what's going on here is, in this case, and I'm going to just make this kind of a dashed line, that is what's known as the axis of symmetry. It isn't always the y-axis, but for this one it is. And the axis of symmetry always goes through the vertex. For this one, the vertex is at 0, 0. Okay, so for y equals x squared, we've got a parabola that opens upward. The vertex is at 0, 0. And the axis of symmetry would be what? X equals 0. So that dotted line, the equation of that dotted line would be x equals 0. Okay, do you have any questions about this particular graph?
No.
All right, so now let's see here. I'm going to erase all of this. And I'm going to change it to red. And we're going to graph y equals 2x squared. And I'm going to use the same x values. -3 to +3. Now, order of operations, y equals 2 times -3 squared. Would you take the 2 times the -3 first, or would you square the -3 first? What would you do first?
It's parentheses first, so you would square it first.
Right, well, in fact, exponents first, but yes. So this would be 2 times 9, which is 18, okay? And then when x is -2, you'd have 2 times -2 squared, which is 2 times 4, which is 8. And then y equals 2 times -1 squared, which is 2 times 1, which is 2. What I want you to see is this is just like that, but then we multiply it by 2. So these values are just double those values. 2 times 0 is 0, 2 times 1 is 2, 2 times 4 is 8, 2 times 9 is 18. So I could have just started with this table, taken my y values, doubled them all, and gotten those, okay? Because it's 2x squared as opposed to just x squared. So what does that look like graphically? Well, -3, let's see, 18, that's way up off the graph. But how about -2, 8? That would be right there. And then -1, 2 would be there, 0, 0, 1, 2, 2, 8. So my graph looks like that. Same shape, same vertex, same axis of symmetry, but it's climbing steeper, faster, because for the same x values that we had over here, now they are being doubled. So for instance, this x value is now twice as much. This x value is now twice as much. This x value, oh, it's off the graph. Do you see what's going on there?
Yeah.
Okay.
Yeah.
All right, good. So now let's get rid of this. All my extra scratch work there. And let's do this one in green. Y equals 1/2 x squared. Again, I'm going to use the same inputs. Let's see here what happened there. So y equals 1/2 times -3 squared, which is 1/2 times 9, which is 9/2. Oh, there's that x squared again. Well, we had x squared and we got these values. We had 2x squared, we doubled those values. We've got a 1/2 x squared. So these values, these y values are going to be half of those. 1/2 of 9 is 9/2. 1/2 of 4 is 4/2 or 2. 1/2 of 1 is 1/2. 1/2 of 0 is 0. 1/2 of 1 is 1/2. 1/2 of 4 is 2. And half, I put 9. I said 9/2 and I wrote 9/4 here. That's not very good. Okay. In other words, all of these values are half of all of those values. Okay? 3, let's see, -3, 9/2 is 4.5, so that's right about there. -2, 2. -1, 1/2, 0, 0, 1/2, there, and there. So that's opening wider than the black one that was y equals x squared. Because now all of these x values are being cut in half, okay? These y values, not all the x values, but the y values, these y values are half of what the black ones. So the green y values are half of the black y values, and the red ones are twice as much because we doubled it and we halved it. Are you following what's going on there? That kind of?
Yeah.
Okay. Good.
Yeah.
All right. And now let's see here. I'm going to erase all of this. And let's go with blue this time. Let's take a look at y equals -x squared. X, y, -3, -2, -1, 0, 1, 2, 3. Okay, now order of operations. Y equals negative times -3 squared. Y equals -9, or just -9, right? In other words, you would take the x and square it and then apply the negative sign, okay? So this is just like that, but there's a negative sign after you square it. So what are these going to look like compared to these?
They're going to have negatives.
Right, so they're going to be opposites. -0 is still 0. Well, what's that going to look like graphically? Well, -3, let's see here. -3, -9 is there. -2, -4 is there. -1, -1, 0, 0, and there. And we get a graph. It's the same shape as the black one that's going up, only now the blue one is going down. The axis of symmetry is still the y-axis. The vertex is still at 0, 0. But now, because there's a negative coefficient in front, the parabola opens downward. All right? So from this, we can generalize the following information. If we have an equation in the form y equals ax squared, if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. And the axis of symmetry is at x equals 0, this dashed line, and the vertex is at 0, 0, or the origin. Okay? So that's parabolas in the form of y equals ax squared. A is positive, it opens up, negative, it opens down. If A is 1, it looks like the black graph. If A is larger than 1, it climbs steeper, it's narrower. If it's between 0 and 1, it opens up wider. All right? Any questions on that?
No.
Okay, now
No.
we're going to go to a new page. And let's see here. Two, three, 4, 5, 6, 7, 8, 10, 5, 5, 5, 10. Okay. And we're going to start again with y equals x squared. Let's see, I think I've got, let's go back to the black one there. Okay. And I'm going to use the same. So basically, I'm just recopying that first graph I had on the previous page. So this is 9410149. And the graph looks like this. Okay, so there we are back at y equals x squared. Here, let's do this just to be consistent. Let's make this black. Okay, now A is 1. What I'm going to do now is I'm going to add or subtract a constant. So I'm going to go like y equals x squared plus 2. Okay. And again, I should have made that a different color. Let's make that red. So y equals x squared plus 2. And we'll make a table. X and y, -3, -2. Okay, I'm lazy. I don't want to have to recalculate all of this. How are these values going to differ from those values?
You're going to add that to all of them.
Exactly, because we've got x squared plus 2. So 9 plus 2 is 11. 4 plus 2 is 6. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. 4 plus 2 is 6. 9 plus 2 is 11. So all of the y values had an increase. They all got a $2 raise. So what is that going to do to the graph? It's going to move it up 2 units. Okay, so the shape of the graph is the same. If I could have just magically taken this black graph, whoops, well, anyway, the black graph there, and just moved it up 2 units, I would have gotten the red graph. Everybody see that all right?
Yes.
Okay. Now let's take a look at y equals x squared minus 3. Oh, notice that the vertex also moved, didn't it? Now instead of being at 0, 0, it's at 0, 2. Okay?
Yeah.
All right. So now, x squared minus 3, how does that compare with just x squared?
You're just going to subtract 3.
So 9 minus 3 is 6. 4 minus 3 is 1. 1 minus 3 is -2. 0 minus 3 is -3. 1 minus 3 is -2. 4 minus 3 is 1. And 9 minus 3 is 6. So what's my graph going to look like compared to the black graph?
Move downward
How far?
3 units.
Excellent. So let's see, 1, 2, 3, 1, 2, 3, 1, 2, 3. See, I'm not even using the table. I'm just going in here and saying, oh, I'm just going to move those values down 3 units. Same shape, but move down. So what does this do? It moves the whole thing up or down, which also moves the vertex up or down, doesn't it? Okay?
Yeah.
Questions there?
No, I don't have any.
All righty. Next page. Let's see here. It's green, which is just fine. Green works. I'll switch it over. Go back to black here. Okay. 5, 10, 5, -5. And we're going to go with y equals x squared again. Surprise. That's just sort of the starting point, the starting graph for all of these things. Okay, so this is 9, 4, 1, 0, 1, 4, 9. And here, and here, and there, and there. All right, now let's do this. Let's graph y equals x minus 2 squared. So instead of putting the constant outside like we did here and here, here and here, we're going to put it inside the square. Okay? Now, here's what I want to do. And this is going to be kind of tricky, but we'll think this through. Instead of changing, or instead of using the same x values, now I want to use the same y values. Okay? I want my outcomes to be the same. But my equation is y equals x minus 2 squared. So as soon as I take whatever x value goes right there and I put it right there, I'm going to subtract 2 before I square it. Right?
Yes.
Okay. In fact, to make this easier to see, let's go down here and let's go to these values. Okay. So here I've got 0 and I square it. If I want to square 0 to get that, what does my x value have to be right here so that I have 0 inside?
0.
No. What minus 2 would give you 0?
2.
2. Okay, let's go down to this one. What minus 2 would give me a 1, and then 1 squared would be 1?
3.
And then this one. What minus 2 would I square to get 4?
6.
No.
2 or 4.
There you go. What minus 2 would I square to get 9?
5.
So what just happened to my X values?
They all have +2. They all got another 2.
So my black graph, or rather my red graph, what's it going to look like in terms of the black graph? My Y values are all the same, but what do my X values do? I'll tell you what, let's just start graphing them. -1, 9. Wait a second here. I think that's supposed to be a 0. Sorry. 0, 4, 1, 1, 2, 0, 3, 1, 4, 4, 5, 9. What happened to the graph? How does the red graph compare to the black graph?
They moved 2 spots over to the right.
Yes. Okay. Here, this is the bonus Jeopardy question. Okay. What do you think that graph is going to look like compared to the black graph?
Is that going to be 4 spots to the left?
Yes! Victory, touchdown, basket, whatever. Good job, Greg. Yep. So here's the deal. If we've got something in the form of y equals ax squared, let's see, no, we already did that one. Y equals a times x minus h squared. Okay. If h is positive, it's going to move to the left. And if h is negative, it's going to move to the right. So that's kind of weird because if we go back, okay, let's go back here. Come on, get this thing out of the way there. All right. Way back to the beginning, y equals x squared. If we changed the coefficient, if we made it larger, it was steeper. If we made it between 0 and 1, it opened wider. If we made it negative, it opened downward, okay? And then here, if we add a constant, it moves the graph up. If we subtract a constant, it moves the graph down. So that kind of does what you expect. But here, it's kind of the inverse of what you'd expect. X minus 2 went 2 to the right. X plus 4 went 4 to the left, okay? So where does that put us? Well, okay. Come on, I need this thing to move out of the way so I can click on the next page. If we've got something in the form of y equals a times x minus h squared plus k, if a is greater than 0, the graph opens up. If a is less than 0, the graph opens downward. The axis of symmetry is at x equals h, and the vertex is at h comma k. Now, for example, let's say I've got y equals 2 times x minus 3 squared plus 4. This is a parabola. It's going to open upward because a is positive. Because a is a positive 2, it's going to be slightly narrower. Okay. It's going to be moved 3 units to the right and 4 units up. Okay. Well, the axis, let's see here. The axis of symmetry is at x equals 3, and the vertex is at 3 comma 4. In general, this is x equals h, and this is h k. Okay, so the axis of symmetry is at x equals h, the vertex is at hk. The thing you got to be careful of, inside inverse, outside obvious. And let me explain that a little bit more here. Okay. Let's say I've got this equation. Y equals -3 times x plus 5 squared minus 2. This is going to open downward because it's a -3 coefficient. So it's going to open, I don't stand on, I should stand on my head anyway. The parabola is going to open downward. Okay. The axis of symmetry is at x equals -5, and the vertex is at -5, -2. So inside inverse, outside obvious. Okay. How are we doing?
Good so far.
All right. Now, let's take a look at some specific graphs, and then I want to look at how that works on Webassign. Let's see here. Okay. I'll just erase that. And then let's say I've got y equals 2 times the quantity x minus 2 squared minus 1. It says find the vertex and axis of symmetry of the graph of each function. In fact, they wrote it as a function. So let me use function notation here. F of x. Okay. So find the vertex, axis of symmetry. Do not graph it, but determine whether the graph will open upward or downward. Okay. So the vertex is at HK, which would be what? 2, -1. Okay. The axis of symmetry is at x equals 2. The parabola opens upwards because A is positive. Okay, so the vertex is at HK, the axis of symmetry is at x equals h. So this value is the same number as that number. You okay with this?
Yes.
Yeah.
All right. Okay, now what I want to do is I'm going to go to Webassign and show you how that works. If we can get this thing to work here, and we'll open this back up. And let's see here. And so okay, we're almost there. Okay. 10.4. Okay. Why is it giving me that? That's not what I wanted. Oh, here we go. Okay. Okay. All right. Now, so here's a Webassign problem. It says, make a table of values for each function and graph them on the same coordinate system. And we've got f of x equals x squared, g of x equals 4x squared, and s of x equals 1/4 x squared. Okay, now I want to talk about the difference between graphing on graph paper and graphing in Webassign. Graphing on graph paper, what I would have you do is to find the vertex and the axis of symmetry, and then make a table And in fact, let me switch over to the other screen here. So for instance, if you were going to graph f of x equals x squared, the vertex is at 0, 0, and I have you use 1, 2, 3, -1, -2, -3. Okay. Now, and so we get what, 9, 4, 1, 1, 4, 9, like we did before. In Webassign, to get the graph of a parabola, you only need to plot 2 points, but you must plot the vertex first. If you plot the other point first, it won't know what you're doing and your graph will be incorrect. Okay, so let me take this and let's go to Webassign and let's graph f of x equals x squared. So I'm going to click on the parabola until it turns blue. Okay, f of x equals x squared had a vertex at the origin and then one other point. Well, I don't know if you'll recall. In fact, let me go back here and just show you. So I can use any one of these ordered pairs. I'll just use 1, 1. Okay. So here's my second point and boom, there's my parabola. Okay. Any questions about that? Now we're going to go back and graph g of x equals 4x squared. So let's go back here. And what I would do, again, if I was graphing it on graph paper, let's see. Oh, this is going to be what, 4 times that. So that's 36, 16, 4, 0, 4, 16, and 36. I just took the x squareds times 4. Okay. And I could plot those points on a grid, on a graph, and I'd get a parabola. For Webassign, all I need is the vertex and one other point. So for Webassign, I don't have to find the whole table. What I would do is find the vertex and then maybe just go one integer value to the right or the left. So if its vertex is at 0, 0, I might choose 1 or -1. Okay. So now let's come back here and click on that. We're going to go 0, 0 and 1, 4. Okay. Any questions there?
No.
All righty. Let's go back to the third one. Again, my vertex is at 0, 0. Again, if I was going to graph this whole thing freehand, I'd complete the whole table. But to do it for the Webassign, I just need one value. How about when x is 1? What would s of 1 equal? That would be 1/4 times 1 squared, which is 1/4 times 1, which is 1/4. In fact, this is going to be what? 9/4, 4/4, 1/4, 1 and 9/4. That's just what? 1/4 of these values. But I just need the vertex and one other ordered pair. Okay. So now I'm going to go back to the Webassign screen, make it blue, 0, 0, and 1, 1/4. Okay, well, let's see. I'm going to plot it right about there. Oh, boy, that's not at all what I wanted. I wanted it to be at 1, 1/4. So now what do? Well, I just graphed the third parabola. So I'm going to go over here and open it up. There's my first ordered pair, my vertex, 0, 0. My second ordered pair, I want it to be 1, 1/4. Okay. Yay. I got them right. So you see how that worked?
Yes.
Okay.
Yeah.
Good, good. Let's see. I think we've got time for one more before we quit for the day. Let's take a look at number 11. So we've got f of x equals 6x squared. G of x equals 6 times x plus 7 squared. And s of x equals 6 times x minus 6 squared. Okay. So now I'm just going to do the Webassign part. It's still, let's see, graph in the form y equals ax squared, the vertex would be at 0, 0. If x is 1, what's y going to be? Well, 6 times 1 squared, 6 would be 6, right? Okay, we okay with that?
Yes.
All right.
Yeah.
So we're at 0, 0, and 1, 6. Okay, now let's go back here. How is this graph going to compare to that graph?
It's going to be 7 to the left.
Correct. So you know what? Let's not even find any points. Let's just go back here. So if I take the origin, 0, 0, and I go 7 to the left, it's going to be right there. Okay? If I take 1, 6, and I go 7 to the left, 1 plus 6 is going to be right there. And there you go. See what I'm saying?
Yeah, I get it.
Yeah.
Okay, let's do the third one. What's this one going to look like?
Six to the right.
So there and there. And voila. You see what I'm saying?
Yeah.
Okay, I've got time. We're going to do one more. Let's do this one. Okay. So where's the vertex at?
Three, 9.
So 3, comma, space, 9. Where's the axis of symmetry at?
Would it be at x equals 3?
Good job. Absolutely. Okay, now I'm going to graph it and I'm going to start with a vertex, which is at 3, 9. Okay. But I need a second point. So let's go back to our screen where we can calculate stuff. And we've got f of x equals x minus 3 squared plus 9. And our vertex was at 3, 9. So let's go 1 to the right or 1 to the left. Do you want to go to 2 or to 4?
We can do 2.
2, okay. F of 2 is the quantity 2 minus 3 squared plus 9, which is the quantity negative 1 squared plus 9, which is 1 plus 9, which is 10. So my second point is going to be 2, 10. All right? And there we go. Any questions?
No.
All right,
No.
so what we've looked at today was equations of the form y equals a times x minus h squared plus k. If a is greater than 0, it opens up. If a is less than 0, it opens down. The axis of symmetry is at x equals h, and the vertex is at hk. Make sure when you put in the axis of symmetry into Webassign that you use x equals. Also, when you graph, make sure you graph the vertex first and then a second point that you find by plugging it in here. And I would just go one to the right or one to the left from the vertex to find that second point. All right. Tomorrow, we're going to come back and we're going to look at equations of the form that. And we'll find the axis of symmetry in the vertex using some different formulas that I will introduce tomorrow. So your Webassign assignment sort of combines both forms. So if you get into problems, let's see here, let's go back to Webassign. And you get into, see, these are all of that form we talked about. That one is, now it's a different form. So from there on out, if you want to hold off till tomorrow, you can, or if you want to look at the videos provided by the authors, you know, on Webassign, you can do that and work ahead if you want. But anyway, tomorrow we'll pick it up from there. So have a great day, have a great afternoon, and I'll see you tomorrow if I don't see you at 1:15.
Thank you. Have a great day.
You too.
Thank you.